All right, so good morning, everybody. Super excited to kick off our grand rounds, right? I'm going to be talking about every other coronavirus, not COVID-19, because we've all belabored that point, even though our next grand round is to do with it.
Sorry, guys. We did not plan this.
Interesting.
But for our movie buffs, my presentation might contain one or two movie references. That is a picture of Will Smith and Mark Wahlberg from The Other Guys, which is why I put it in.
So Pharaoh.
Yeah, what did I say?
You said Will Smith.
Sorry, yeah.
Close.
All right. So let's get started, shall we? All right. So here, I'm going to explain a little bit about my inspiration for this topic and my personal journey. So here we can see I took my vacation back in December, and I went to the World Cup in a little place called Qatar. Okay. When I came back, the point of this whole story is when I came back on the day of that I was supposed to leave, I got flu-like symptoms and then traveled back home and then tested positive for COVID-19. Then I decided to take another trip this last month, and I went to yes, to another place called Saudi Arabia, right?
Focused on that region.
Yeah. So my biggest fear was that on my trip back I would get sick because I had basically 4 flights and it was going to be 48-hour travel. Unfortunately, as fate would have it, I got sick again. Right. Prior to that, my sister came and visited me. She gave me whatever virus she had. I got over that. I went to my trip. And as I was coming back from my trip, there were like so many people. As you can see how crowded it is, it's very easy to transmit viruses. So I ended up contracting something. It wasn't COVID because I checked, but it was something and it was very annoying. So
You had your meningitis shot.
Yeah, that's the big. That's the classic association, right? You go to Hajj and you don't get a meningitis.
well, let's just keep going.
Classic association ever.
Okay. Well, now as we all know, especially in like recent pop culture, pop media, whatever, modern culture, they talk a lot about variants, right? As we can see from this picture, COVID-19 had a lot of variants, and there's different variants of the different coronaviruses, which reminds us of this picture. I don't know if anybody knows what that is. No. Okay.
That's Thor.
So it's from Loki, and then it gives rise to our Kang variants. So no one's getting it.
Sorry.
All right, it's Marvel, the most recent, yeah. Okay, all right, no Marvel fans, fine. This is a bit wasted slide. Okay, good. We got one person.
It's Tristan.
All right, good. Well, now we can get to the meat of it. So that's enough of introducing everything. So presentation is going to be broken down into just a brief overview of coronavirus. Then we'll talk about the other coronaviruses, touch on the timeline, case definition, some of the reservoirs. We'll start with SARS, the original SARS, then go to MERS, and then our common cold or community-acquired coronaviruses at the end. And then, I'll just do a brief comparison of the coronaviruses. So for a coronavirus, there are a large group of different type of viruses, usually infecting mammals, birds, and before SARS, they were really just mild, like common cold viruses. But now we've seen more severe community-acquired respiratory infections with these viruses, and they do affect a wide variety of animals, and they have been known to cross the species barrier. So just based on the structure of the coronavirus, it's spherical, it's pleomorphic, it's enveloped, and it contains a single-stranded positive sense RNA. There is like this nucleoprotein within a capsid and this matrix protein, and then the envelope, as you can see, it has a club-shaped glycoprotein projection. So you can see like the spike protein labeled S, the membrane protein, and then the envelope protein. And then as we know from our recent COVID vaccines, the vaccine targets the spike protein on the coronavirus. So just basically on the classifications. So the coronavirus is part of the orthocoronavirinae, and that's one of the two subfamilies of nidovirales and riboviridae. And then you can divide it into the 4 different sections. So the alpha, the beta, the gamma, the delta coronavirus. And mostly the alpha and the beta coronaviruses infect mammals. And the gamma and the delta infect birds. All right, so a little bit of a busy slide. I need my notes for this. So if we look at the upper left, I guess in this picture they used COVID-19. So the virus, it binds to the ACE2 receptors. Then there is this protease on the side here, this green, which then allows fusion with the host membrane, and then it becomes endosized into the actual cell itself with this another protease, that furin protein. And then it allows the virus to leave the cell. It then uncoats and it goes through, it releases the viral RNA into the cytoplasm, and then it gets translated by the viral proteases. And then it yields its protein, and this drives the synthesis of the RNA, the negative strand RNA, which then codes into the positive sense RNA. And then on the right, the translated structural proteins and the genomic RNA are then assembled into the viral nucleocapsid, and then subsequently released. So just kind of a brief overview of how the replication in the cell goes. So then just also talking a little bit about host defenses. So we do have, our mucociliary activity, which is usually supposed to clear our airways of this matter, but the coronaviruses can infect these cells of the ciliated epithelium. Interferon has also been shown to protect against the infection. And before we had common coronavirus infections, there were specific antibodies in our nasal secretions that protected against this infection. All right, so now that we've touched a little bit about the overview of our coronaviruses, we can jump straight into our first virus. Our first coronavirus, or SARS, or severe acute respiratory syndrome. So let's jump on our plane and we fly to the little country known as China. Okay.
Little.
Specifically in the area in red, Guangdong. Sorry, I
Let me eat.
Okay.
Break away.
Okay, great. All right. So off to Guangdong we go. Okay. But the definition of SARS would be an individual who had a laboratory confirmation of infection, so either who meets the clinical case definition or someone who's worked in a laboratory with live SARS coronavirus. So the clinical case definition would be someone who's had fever or documented fever Someone who's had lower respiratory tract illness, so like cough, shortness of breath, difficulty breathing, radiographic evidence of lung infiltrates, and has no other alternative diagnosis. So we've seen a lot of this with our COVID-19. And then laboratory diagnostic tests would be, detection of the virus in a viral assay or detection of the antibody. So like a rise in antibody titer either from negative or positive with a 4-fold increase. Anyway, here's the timeline. So I tried like this new zoom in feature. So I'm going to see if it works. If it gets messed up, then I don't know what to do. All right, let's see. So this is a timeline that I made. I tried to hyperlink it. I'm not going to hyperlink now because I might mess up the zoom in feature. So I'm just going to do my own thing here. All right, so November 2002, we have a SARS outbreak in our beautiful city of Guangdong. Beautiful province of Guangdong. Okay, let me try this again. Okay, and then here we go. Okay, cases of SARS were first noticed there in November 2002. Like I said, between the time period of November and February, there were about 792 cases. And most of the cases disproportionately are healthcare workers and contacts. The first case was a physician from Guangdong who had traveled to Hong Kong 5 days after the onset of his symptoms. Then the other cases in Hong Kong developed those who were in contact with this said patient or secondary cases, people in the hotel, and the other index cases in the different countries like Singapore, Thailand, Vietnam, Canada. They were all travelers returning from the same province. Let's see. So in February 2003, the WHO issues a global alert, and then in March, declares SARS a global health emergency. Jumping ahead, the first identified in March and February, the virus spread rapidly. After that to China, Hong Kong, Vietnam, Thailand, Singapore, and then eventually to Europe, Canada, and the United States. And then that's when they issued this several travel advisories. And then moving on to the end of it, in April 2003, SARS spread, like I just mentioned. And then in July 2003, they declared SARS contained. And then in 2004, they declared that it was officially eradicated.
Can I interject here? Does anybody know kind of why the virus fizzled out and become this pandemic like SARS-2?
Was it more deadly?
Yeah.
It was more deadly.
Yeah, exactly.
Yeah.
So people either had symptoms earlier and they isolated, it was more deadly. Also, the public health structure was stronger. So Hong Kong at that time had they still do, but more so. So people were really on top of it. I think there was less, less the delay.
Oh.
I was actually at the CDC during that time, 2003.
Oh, wow.
I was in the Emergency Operations Command because I studied Mandarin in college and
Oh.
so we were advising. I worked on the surveys for them, and then I also helped take all the physician calls from the United States. So it was a big deal.
Oh, nice. Okay.
Yeah. Yeah, I was so sad to see it come back with those two.
Oh, yeah. That's good to know. Yeah, so by July 2003, no new cases were reported, and WHO lifted its remaining travel advisories. And then at the end of 2003, beginning of 2004, they had 4 small outbreaks at the end, but 3 of the outbreaks were related to laboratory transmissions, and 1 was presumably from animal sources. But since mid-2004, no new cases have been reported. Okay. If I do that, okay, good. Yeah, so just kind of the wide scope of the outbreak. From 2002 to 2003 outbreak, there were 8,096 cases with 774 deaths, and a case fatality rate of 9.6. Mostly older people had a higher mortality rate, and the cases occurred in about 29 countries. And the United States had about 27 probable cases with no secondary cases and no deaths. So like I mentioned, we had some smaller outbreaks. They had 2 outbreaks that originated in laboratories. It was only a single case. A third one in April 2004, there were 9 cases, but no deaths. And then a 4th outbreak in 2003 to January 2004 with 4 relatively mild and separate cases. Just quickly going over the host. Oh, where's my picture? Oh yeah, there we go. Yeah, so the Chinese government, they led an effort to kill all the palm civets, like this cute guy here. He's apparently a culinary delicacy in China.
Everything there is.
Apparently they needed to kill him. They said that there was no direct link between the civets and the SARS, but they did isolate some SARS coronavirus early in the epidemic, which were related to the civet coronaviruses.
So interjecting too, of course, it's the animal markets, right? So what happens is there's cross between the animals in the markets. So there's live markets, especially in that part, not all parts of China, but that part particularly. So that's, I think, as you very well said, it's probably from there, but it's really a lot about, really, honestly, it's about a lot of stressed animals together. And that's why the virus is taking off. And unfortunately, it's probably why it took off again. It's because encroachment on habitats, and then bats, and then encaged animals. They're called wet markets. So, yeah. So, yeah, goodness.
Life market. I should go after the life markets, not the animal.
Is it all respiratory failure and ARDS, or do they have like thrombotic complications like with COVID now?
I mean, from as far as I can see, yeah, they didn't mention anything about thrombotic. Yeah, mostly respiratory ARDS.
So less transmissible than COVID-19 compared like if you were, compared to.
Yeah, because there's so many fewer cases.
It seems like COVID-19 must be more transmissible.
Less fear.
It's the whole thing that they got symptomatic quickly, while with COVID, you have this period, you're asymptomatic and you're just spreading it.
Okay.
And that's why it was so
Yeah.
So that will vector R naught, that's right.
So there was also studies which showed that there might be a relatively high percentage of horseshoe bats in China that had a similar nucleotide sequence related to SARS. And there have been coronaviruses found in that resemble SARS that have been found on bats in continents outside of Asia. So they think, maybe bats give it to the palm civets and then to the host. So just quickly on pathogenesis. So we have limited knowledge on this. Autopsy studies have showed that it usually affects the lung as its early target. And then it is also found commonly in the lung, intestinal tracts, and then patients who died, it was all found in multiple organ systems, including the brain. Just quickly, clinical manifestations similar to our SARS CoV-2. The only thing is you have like a prolonged prodrome, so about 3 to 7 days. You have fever, malaise, headache, myalgias. People don't have any respiratory symptoms during this time, but then at the end of prodrome, they began developing a non-productive cough, and then shortly after dyspnea, respiratory failure, and then sometimes mechanical ventilation. So, your typical symptoms, your fever, your cough, your chills, myalgias, dyspnea, headache, and then sometimes diarrhea, chest pain, pleurisy. And then our imaging, nothing that we haven't seen before. So just you might have interstitial infiltrants, similar to like what you would see in ARDS. Could be bilateral as well, pleural infiltrants, peripheral infiltrants. And then our CT scan, which you've seen many of back in our days of COVID, our ground glass capacities. All right, now shifting gears over to our MERS, our Middle Eastern Respiratory Syndrome. So you know what we got to do? We have to jump in our plane. All right. Yeah. I guess she got the basic package. And we are heading over to Saudi Arabia. So who knows? Maybe I had MERS. All right, we're back to the Zoom in thing. So we're gonna do this again. Okay. Yeah. Wait. No. Oh no.
This is
not
the
one.
old timeline.
No. Wait. Wait.
But
wait.
it's
Oh, there.
working.
All right. Yes.
That one.
Okay. All right, guys. Yeah. Here we go. Onto our timeline. So we're heading over September 2012. I'm going to read that. Just go straight to the slide. In September 2012, there was a novel coronavirus that was reported. It was from a man, a sputum, a sample of a man in Jeddah, who was admitted to the hospital with pneumonia and also AKI in June 2012. Shortly after that, there was an almost identical virus that was detected in a patient in Qatar with acute respiratory syndrome. And it was noted that the patient recently traveled to Saudi Arabia. Okay, back to our timeline. We go over to April 2013. WHO then issues its first global alert about MERS.
7 months later.
Yeah, and then May 2013, MERS cases have been reported in several countries in the Middle East. Going to the slide. Yeah, in April 2013, there's a cluster of 23 confirmed cases, 11 probable cases of MERS that was detected in Al Hassa in Saudi Arabia. Majority of cases were person-to-person exposure in a single hospital, and then there was a sharp increase in cases in Saudi Arabia and the UAE in March and April 2014. Then over in April 2014, we had our first case of MERS in the United States. Yeah, so in 2014, we had our first case in America where there was an American healthcare worker in his 60s who lived and worked in Riyadh, Saudi Arabia. But then he traveled back to Indiana in April 2014, where he presented for his care. There was also a second case in May 2014, right here in Florida, from a person visiting Saudi Arabia.
Was that you, Jaraad?
Yeah, it could be.
Change that to 2023.
Yeah, and then from there on, in June 2018, WHO had reported that MERS had spread to over 27 countries with about greater than 2,000 cases, 790 deaths in total. And then in January of 2023, there hasn't been any reported cases so far for the year. So just touching on the scope of the outbreak so far, since April 2012, there has been about 2,600 laboratory confirmed human infections, to be precise, 2,603. And the actual number of cases might be higher, but it was halted due to the COVID-19 pandemic. Okay. All right, so just going over a little bit about MERS. It is a lineage of the beta coronaviruses that are found in humans and camels. And it is different from the other human beta coronaviruses, like our SARS and our common cold coronaviruses, but they are closely related to bat coronaviruses. So possible like sources and reservoirs. So our camels appear to be the primary mammal host for MERS, but also bats, those that have been studied in Europe, Africa, Asia, Middle East, have found that their coronaviruses RNA sequences found in the bat fecal samples were very similar. And it has been shown that MERS cause asymptomatic infections in Jamaican fruit bats. So for our case definition, so it would be a person with laboratory confirmation of an infection of MERS, irrespective of clinical signs and symptoms. And then our probable case would be someone who's had a febrile acute respiratory illness, who has, some kind of clinical, radiological, histopathological evidence of pulmonary disease, who also has either a direct epidemiological link or someone who has resided and traveled to the Middle East, where there's those camels or other humans who have been infected with it. And then those who had either testing was unavailable or testing was negative or inadequate. So these are the probable cases. So what kind of clinical symptoms are we looking at? Similar to other coronaviruses, you have your fever, cough, shortness of breath, myalgias, your abnormal chest X-ray, chest CT. And then the most serious symptoms people have, like pneumonia, ARDS, AKIs. But these patients are usually younger, but there have also been mild asymptomatic cases as well, especially those who's had contact with camels. And then, just our standard imaging, nothing that we haven't seen before, with our ground glass opacities on our CT, our pulmonary infiltrates and opacities. All right, so winding down here, we're going to go over our community acquired respiratory coronaviruses. So where are we going for this one? Well, we're going everywhere. Okay, so we're hitting everywhere with Porky the pig. So our first coronavirus here, the HCoV-OC43, was first identified in the 1960s. And it is a member of the beta coronaviruses. In 1967, there was a first identified case of common cold by researchers in the UK and the US. Then in 1984, they did the complete genome sequence that was published, making it one of the first coronaviruses to be sequenced. And then in 2004, researchers have found that in addition to causing like common cold symptoms, it can also cause severe lower respiratory tract infections in immunocompromised individuals and and then our other coronavirus, our HCoV-229E, also found in the 1960s, a member of the alpha coronavirus. In 1965, it was first identified in medical students in the UK and the US who had developed common cold-like illnesses. 1967, it was then isolated in laboratory and confirmed to be a human coronavirus. And then in 2005, they kind of hypothesized that it might have originated in bats and then jumped to humans several times over. So both of these viruses are RNA viruses that have high mutation rates, which is the reason that they're able to circulate in the human population and cause periodic outbreaks. Oops. Well, that one kind of sprang on us, but we're heading over to our last set of coronaviruses now.
It's only women hanging out.
Yeah.
Pig was a man. Pig was a man.
In the seats.
The South.
Even the pig got it.
Well, I mean, blame Google, right? That's what happens.
I know.
You couldn't like Google nice woman.
So-
Are you afraid of flying?
I know, right? I just Googled airplane funny and that's what came up. So
You
sorry.
set the Concorde on fire though. I guess it's fine.
So we're heading over to the Netherlands for this one, which is why it's called HCoV-NL, Netherlands. So it was first identified in the Netherlands in 2004, a 7-month-old with bronchiolitis, and then also subsequent studies have showed that it's also globally distributed. And then we're back over to China. In Hong Kong, where our HCOV HK, Hong Kong, was first identified in 2005 in China. So both of these are considered mild respiratory viruses, and usually people recover without any complications, and it can cause your typical symptoms like your fever, your runny nose, sore throat, and then in some cases it can cause bronchiolitis or pneumonia.
So another fun fact, HKU, Hong Kong University, which is the primary med facility there,
Oh,
which I
okay.
interned in.
Oh.
Right.
Oh. Okay, well,
They do a lot of good work.
well, I'm glad you're here for this presentation.
Yeah, no.
All right, so just some general epidemiology for our community-acquired viruses, which we already know. You have your waves of infection, usually goes through our community during the winter months, which is in contrast to our rhinovirus, which I think is in the warmer months. And 1 in 5 colds is usually due to coronavirus. Our symptoms of human coronavirus, are runny nose, sore throat, headache, fever, cough, nothing crazy. Just briefly on pathogenesis. So the coronaviruses are extremely fastidious and they only grow in differentiated respiratory epithelial cells. The infected cells become vacuolated, damage cilia, and they become syncytia, so you can see right here. It's like a cell with multiple nuclei in it. Oh, and Dr. Tony is here just in time.
You can tell us which one you got, or
Yeah.
the end of it.
I don't have the answer to that. I should have. It would have been cool. Wait.
Make up something. No one's gonna question.
Right, that's true. That's true.
Yeah.
Okay. All right, and then for our final slide, glad Dr. Tony can join us. Yeah, the presentation.
Well, next time you can go see my study paper.
He's in-
You're not a comment.
Yeah, so just comparing quickly our different coronaviruses. So our COVID, our MERS, SARS, and then common cold. So, their origins differ. So Wuhan was for COVID-19, MERS, Saudi Arabia, Guangdong for our SARS, and then, we went through where our other common coronaviruses came from. Transmission, so for COVID-19, you can get it from touching, eating infected animals, human to human transmission. For our MERS, infected camels, drinking their milk, and also transmissions between humans and their close contacts. SARS, it was believed to be spread from bats, which then infected civets, and then transmitted usually through humans with close contact. And then, our basic coronaviruses, just being in contact with infected humans or touching surfaces with the virus on them. And then cases, we have a lot of COVID-19 cases. Our MERS cases, so we had greater than 2,000 cases. And then our SARS cases, and then our human coronavirus, there's millions of cases. So that kind of wraps up my presentation on coronaviruses. A bunch of references, I just put some in here. And then just kind of ended some general advice. When Dr. Tony says the constituted, just know it's a trap.